Going to start by tearing down the turret at the top, taking it off and repairing the damage that occurred when I was doing a tow test and the weights fell over and hit the turret as well as the rest of the robot, but damaged the turret just a bit. It's a bit bent up. So I'm going to take it off and then disassemble it and go through the process of how it was put together. So first things first, we'll take the gun off. We just unplug it. And I'll take the camera off, which simply has two small, in this case 440s I believe was used instead of metric. Okay, and this is a standalone camera. This was the Firefly, and this camera is just currently used. It does have a video out which can be fed to the wireless video transmitted. But it currently is just standalone, just for getting footage of whatever mission the robot was on. All right, this camera is a night camera, and it is anchored to the gun directly, and it's plugged in currently, so this is set up for night vision. It doesn't have to be. This camera can work during the day just fine as well. It just isn't as good a quality or as wide angle as you might want for daytime driving. So it just unplugs, and then the gun just slides up and out. And it has these spacers on the side so that basically any airsoft gun could be used on here as long as it fits within the width, and then you can find a place to put spacers on there so that it would fit in there. This on the bottom then is where the BBs actually feed up into the gun. And the motor is back here. It is exposed where it is because I chopped off the whole handle off of the airsoft gun and removed quite a bit of the other parts off of here because they just weren't needed on the tank. Alright, so here's the turret. It's able to spin completely around and then some. So not a full 2 revolutions, but near. And it basically behaves like a large servo, and I'll explain that as we get into that. And then the tilt is done here. Alright, and so I'm going to go ahead and take it off of here. So to take it off, we're going to do this panel. Alright, and now this could stay open like this if we wanted to leave it this way for working on it and for adjusting the firing rate and the feeder, which are both adjustments right here. That's for the gun. But if we were to tip the robot open, which you just open it up at the front, if we were to tip it open, then this whole thing pivots and it could fall open. So that's why there's an additional screw over here to keep it from flipping back when I open up the robot and maybe forget that it is that front plate is not on there holding it down. So once that screw comes out, then it can pivot. Okay, and so then it pivots back, and you can see inside here there's the feeder coming up from the bottom. The tube that comes up is the flexible tube that feeds the BBs up into the gun. And it has to be very low restrictions in the tube. If there are restrictions, the BBs just don't feed very well. And so it really has to be correct diameter and everything so that they don't jam up on each other. Okay, and let's go ahead and tilt this back. So when I tilt this back, then that tube is now free to come out because it is held in place in here by a magnet that hooks to the feeder. And so that just attaches on there, so it's magnetically held, and that little ring right there is just what's doing that. So I could probably improve upon that, come up with a better system, but for now it works and gives me the flexibility I need for the gun to be able to rotate and tilt as needed. Okay, then the wiring, all the connections that are here are all right here. There's 2 main connectors. Everything feeds to those. The servo control for the guns or the turret, and the lighting and the cameras, the telemetry, everything has to flow up through those two sets of wires there. Then I have a third wire that is going directly to the Pixhawk, which is doing the telemetry only, and it goes up to the radio that's up actually in the turret itself. Okay, so to undo those, they're just a pull connector, so they're easy enough to undo. All right, and there they are. They're just numbered 1 and 2, so I know which one they plug into because they're identical connectors. And then this just unplugs from the Pixhawk. Okay, so now the turret is free to move, and it's on these pins in the back right here, so that it fits onto these rails. So that to put it in, you can't put it in unless you tilt it and then slide it in, so those pins are now engaged. That enables me to tilt this back, and it will use those pins to hold itself, as well as these two little handles, which are actually server handles off of a blade type server. And that just allows it to sit there while I'm working on it and doing maintenance on it. So we're just tilt it sideways and out, and then there's a loose BB, and then there it is. Okay. Alright, and we will get into this part of it in another video, but for now we're going to work on the turret. Alright, here's the turret. It's on a wood stand here that just keeps it up off the ground a little bit so that it's easy to get to the underside of it. Alright, and what I'm going to do first of all is take off the antenna. Okay, that's just the antenna that does telemetry. Alright, and then let's unplug these lights. Alright, this is the feed to the spotlight, which is just a friction connect on here. And then there's actually a little regulator in there, voltage regulator, to drop down the main voltage, which I believe is 12 volt, coming up to that one. Drop it down to what a flashlight, really, that's all it is, focusable flashlight, which gives you a really nice spotlight. And this drops the voltage down to a level that is acceptable for the flashlight, which I believe was just 3.7 volts. Have the option of using it infrared flashlight, which is here. This one is not focusable, however. They do make focusable ones that are infrared. It does have the same voltage regulator in there though. And the option is there to put anything you want on there as an attachment up here. Okay, so then that's the feed for that light. And then this is the feed for the infrared lights. So then that's the feed here for the infrared lights, which are right here and here. They just wired underneath and back up to the other side over here. These are just lights that come off of a night vision camera that has and you could do any kind of infrared light you want to. These were just cheap and easy to obtain, and so I just put them on here and wired them together as two halves. You can see they're rounded because they were made to fit inside of a round housing of an infrared camera. Okay, and then they're just connected together to the same system. They're made to run off of 12 volts, so they're nicely compatible with everything I'm doing here. Alright, on this end, then there's just an O-ring right in here that keeps the antenna on there well. And then this panel comes off the side. If I were to redo it, I would probably use 3mm screws everywhere, but this is mostly 440s. Okay. Just slides up over that, and the panel comes off. I used metal because I knew this was an airsoft tank, and so it's going to take some hits from airsoft BBs. I don't want it to get destroyed quite so easily. Might get dented a bit, but probably not completely destroyed. Alright, and then that is the telemetry transmitter, and it takes the information coming from the Pix Hawk or whatever you want to feed it, it's just serial, and transmits it back to the receiver, which is at the base station with the PC. Alright, and on the other side, we've already unhooked that. There's 4 connectors across the top here. The same screws on either side. And then that panel comes off. And underneath this panel, then we see the end of the servo that is driving the pitch of the gun. Alright, it goes to a gear, and here we'll look at in a minute. And we also see all the wiring that's going here. This is the video feed. It has power to the camera and returning the video signal. And then we have the power going to the gun, a little heavier gauge wire. I believe it's probably 24 or 22 gauge wire, going to the gun motor, which is being driven from down in the main unit of electronics, not up here on the turret. And then these 2 feeds right here, which were just the lights. All right. And it's quite a few wires. There's also an additional set of wires here that is for left and right speaker, or rather microphone, to be fed back to the transmitter. So that audio left and right can be transmitted as well, which the transmitter does support, the one that I currently have. And that way you can have a stereo type setup and actually hear things from the left or right while you're in or watching whatever view the gun camera is seeing. And that way you know if you have an opponent on your left or right based on the sound as well. Alright, so I've made some changes in the lighting to hopefully improve things a little bit, and in the stand a little bit so that it would stay where I want it to stay. So now we're taking off the part of the turret that actually can pivot and tilt up and down. So the cradle essentially is what's coming off, the gun cradle, this piece right here. Alright, so now both of these bolts can now be pulled inwards. Okay, so now the only thing holding this piece on, this cradle, are these 2 bushings. One right here provides good movement so it doesn't jam up, very smooth. Okay, and then the other one, which is right over here, and a little bit tighter and harder to get in and out of there. I believe actually I need to take off the video connector. There we go. Okay, so there it is. Okay, so now it should be free. So there it is. That's the gun cradle. It's very lightweight. And it could be customized for any type of airsoft gun you wanted to put on here. And you can see I've got a little bit of damage in it from the accident that I had. It's a little bit bent in here, but that's easy enough to fix. Okay. Alright, so now we are down to the panning part of the turret. The tilt servo is right there. Okay, it has a gear there on the end. I believe it actually came out of a printer, a laser printer, an old laser printer, and it's a Solar D228 is the servo. I went through a number of different servos and possibilities, and found that one to be a good choice for doing this. And there's the other gear that matches up to it. I don't remember what the ratio is right now on those gears. Okay. Alright, so now we're going to take off this piece right here, which is the panning part. If we tilt this up, okay, you can see what's happening in here. We have a servo motor here. However, it is the potentiometer that normally sets the position for the servo has been disabled, and then this one over here is an equivalent potentiometer, just a much heavier duty one, and it is what provides the positioning for the servo, because I wanted to set my own ratio for how far this turret could rotate versus a traditional servo, which doesn't have nearly the rotation that I wanted, the angular rotation. Okay, so we're going to take off this top piece and remove it out, and the gears that are right in here, this gear is going to go with it as it comes off of there. The rest of this is going to stay where it's at. Alright, and then we will remove just these 4 screws on these corners, and that should come off. Alright, so right over here, then we can unplug also that servo so that that whole thing can feed up through there. We'll just undo these 4 screws. You can see that right now this top edge, because of the accident, is all bent. It should be flush, and it's not. So it'll be a little bit of rework, but not too much. 440 screws once again. But I would probably redo this with 3mm if I were going to redo this structure. Alright, so now it's free to move, slide out. The wires should feed through there. And there we go. Now it's free. All right. Okay, so this piece right here is just a, it's most often called a lazy Susan bearing, or it's a turntable, and it is the pivot for the entire turret that is anchored to. So I had to do some modification because it was square. I needed to cut those corners off so it would fit in there, and then tap those holes right there so that it could fit to the top plate. That actually does, so it could fit onto this piece, obviously. Okay, and then the pot that you see, the potentiometer that you see right there, that one is a 5K pot. I believe it's a 10-turn pot, and it is what, of course, does the positioning for the servo, so that I could get the positioning that I wanted. And it depends very much on your gear ratios. That all has to be figured out if you were going to build something like this. It's going to be pretty much what gears you can get, or if you have a 3D printer, you could print your own, as long as you do something that has a fine enough layer level and accuracy so that you can get reliable positioning. And that's also important on the pot, that you have a potentiometer that is pretty accurate, so that your gun doesn't, or your turret as it turns, it doesn't end up kind of wandering a little bit trying to find its spot. And if your potentiometer isn't a very accurate one, then that will happen. And that's the structure. You can see there's some standoffs there holding it together. There's the bearings. So it's really just a lot of standoffs and aluminum plate, recycled in this case. And that's all there is to this piece. This piece here, you can see the damage that occurred. A little bit bent in here, but that's easy enough to fix now that it's apart. And then the bearing, or the gear rather, it's right here. And all the wiring that feeds up. There's some angle iron. Okay, and that's pretty much it for the turret.